Two are general and one's just for this class. And I thought I had this set up. Here we go. All right. Well, might even have to turn on the projector. I can see the screen. Why can't you? First, let me get this one. Today and tomorrow, today's over with, okay? But there's Lawson State Community College College Transfer Fair Days for 2018. They started this morning, 9:30 to 11:30. That's over with. But that was on the Birmingham campus, okay? Tomorrow, they're going to be on this campus, Thursday, January 25th. It was 11 more months till Christmas, okay? 9:30 to 11:30. And this will be in the faculty staff dining room. Now, what they call it here is the Bessemer Faculty Campus Cafeteria. It's right next to the cafeteria, right. If you're going down this hallway this way that you're going to turn into the cafeteria, right before you get to the cafeteria, there's doors there and here that you can go in. So that's going to be tomorrow morning, 9:30 to 11:30. Here are the institutions that are scheduled to be here. It's going to take a while, folks. AUM, Mississippi State, Oakwood, University of Alabama is listed a couple times. University of Montevallo, Alabama State, Auburn, University School of Forestry and Wildlife Sciences, and Auburn, Alabama A&M, University of West Georgia, Jacksonville State, Stillman College, UAB, UAH, University of West Alabama, Troy, University of South Alabama, University of Alabama College of Continuing Studies, Athens State, UAB School of Health Professions, University of North Alabama, Samford, Fisk, Mississippi College, Concordia College, Tennessee State University, William Carey University. Now, I'm not familiar with this one. Aveda Institute, Birmingham. Does anyone know that one? I don't. Never heard of it. Huh? Aveda? Someone has heard of it?
It's a hair school.
Huh?
It's a hair school.
It's a what school?
Hair school. Cosmetology.
Oh, I got it. Okay, no wonder I didn't. No, I mean, never mind. Okay, it's not that funny. Okay, now, that's Aveda Institute, Birmingham, Armstrong State University, Faulkner University, Southeastern Bible College, Talladega College, Georgia Southwestern State University, and Berea College. Okay, tomorrow, 9:30, 11:30 to 11:30. Now, I know y'all are interested in this one. Y'all are getting so fired up about math, you want to join the math team next year, right? This is the time to start practicing now. If you're interested, Ms. Geraci is going to be meeting with students 12 o'clock, noon, Friday on the Birmingham West Campus. That's in room C100. Now, if any of you want to start practicing here, you know my office hours, you can see them. We can start practicing here if you're interested. So just let me know too. Okay. Joseph came in, right? Okay, and Al, right? Is that right? Al?
Yeah.
Okay. And anyone else come in? So called roll. So we're missing Amaya, Somalia, and Greg Joy. Is that right? Okay, now y'all are here. Okay. One other announcement, sort of a biggie for this class. This isn't across the board, so don't tell anybody. Okay. I today got the code for this class if you're wanting to use my math lab. Okay? Now, what we're doing now, I'm not sure is loaded yet, but there's a bunch of review exercises there. Okay? They come from chapters 1, 2, 4, 5, several of the past chapters, which have sort of review of what you've done that we're going to be using in this course. Review of what you did. So you can access those now. The stuff in this one, I was fighting with it for the last 45 minutes, ever since I finished lunch. And I have not been able to get to change. The person who gave me the thing has it still listed for last fall's date. So it says it's past due Of course, we haven't even gotten there yet. So I've still got to work on that one. But there are a bunch of review homework exercises that you can do. These will stand you in good stead when you're preparing for the first test and quizzes and tests. So you can start working on those to your heart's content. This is, again, completely up to you. It's beneficial. Use it as much as or a little as you like. It's up to you. Okay? Those are those review exercises. I'll try to figure out how to get this chapter's exercises date changed. I changed them when he was talking with me. When I went back and tried to, they wouldn't give me the block to click on. So I've got to figure out what's going on. Okay, but here's the code for my math lab for those who have it. Fowler, F-O-W-L-E-R, and it doesn't have to be uppercase. Lowercase is fine. And then the following 5 digits: 62322. 62322. All written together. Fowler, F-O-W. Let me put it here. Okay. Let me get my pen activated, if it'll activate. There we go. F-O-W-L-E-R 62322. 62322. Can everybody read that? Oh, shucks, what's wrong with my handwriting? Usually no one can read. No, okay, no one can. All right, so that's how you activate my math lab if you want to use it. It's a good package, has lots of tutorial help. You can work on those exercises all you want to. You have unlimited times to try, keep repeating them. It's a good package. I just don't like the way it tries to grade. Okay, so that's why I don't use it. But if you find out, if you're having, oh yeah, and by the way, since those are review exercises from previous chapters, if you have any problems with them, don't be embarrassed. Please bring those to class, and then we'll go over anything, because the odds are, if you're having problems with it, at least half the people in the class, if they had looked at it, would probably be having problems with it. So don't hesitate to bring any question to class anytime from whatever chapter that we've covered or haven't covered. Okay? So, any questions on that? All right. Now, pretty sure we started this problem last time, right? Graphing rational numbers, and I remember drawing a number line, and we graphed those. Did I have the PowerPoint then? Huh? I did. Okay. I couldn't remember. I knew part of it did, but I didn't remember having this one. Okay. And it's gradually, right? Okay.
That's our 2, right?
What's that?
That's our 2, right?
2, right. And, yeah. Okay. All right. So now we're only missing Amaya and Somalia. Boy, they sound so much alike. Okay. Neither are here. Okay. So what they suggested first, to locate improper fractions on the number line, they just showed one of them. This would be negative 1.5. Okay. This would be, they showed it here, 23 divided by 8. And I showed you one way to do it last time. Break down the house, put the 23 on the inside, and then do your division like that. Or you can do it this way. 8 will go into 23 2 times. 2 times 8 is 16. 16 from 23 is 7. So that would be 7/8. And then you can just do it with 7/8. 8 will go into 7. 8, 7, 5 times. So put your decimal point after the 2, and then the decimal back. Either way you want to do it is fine. 2.878. So when you're graphing that on the number line, that's between 2 and 3, closer to 3. This one would be between negative 1 and negative 2, right smack in between. Between negative 1, 0 and negative 1, this one, 2/3 of the way. Okay, I think you got it. Any questions on that? Okay. There's the number line. You tell me where to put things. Negative 3/2. Did we already do this?
Yes, we did.
Yeah. Do I do it on this graph? Or did I draw my own? Oh, I did. Okay. We already done that. Okay, let's move on. There's the negative 1.5. The negative 0.66666. Okay. It's right there. I don't like that. Okay, this should be over here. It should be closer to -1 than 0. I don't know why they messed it up. It should be a little bit further this way. Okay? Yeah. Question? Okay. 1/2. Ooh, where is 1/2? They didn't show it. There we go. There's 1/2 exactly in between 0 and 1. 1. Got that one. Okay. 23/8. That was 2.875. See, closer to 3. Yep, there it is. And 3 1/4. Okay, 3.25. There would be 3 1/2. That's about 3 1/4. See how to graph things on the number line. Any questions on it? Okay. Now, I think this is about where we were supposed to start today. I just couldn't remember. I knew I drew a number line, but I wasn't sure I used that one. Oh, yeah. I was looking for my mark that was in the other book. And I think we talked about this. There are numbers that are not rational. We talked about them, right? One of these is pi. Now, how is pi defined? It's defined as the circumference of a circle divided by the diameter of a circle. Now, I can almost hear some of you really clever people saying, isn't that a ratio of two numbers? Okay. It is a ratio of two numbers, but if this one's rational, that one won't be. If this one's rational, that one won't be, because the ratio turns out being an irrational number. The pattern never repeats itself. And you might say, well, maybe they just didn't take it far enough. Some of these clever computer whizzes, I've read this somewhere, have taken pi to the, I think something like 3 millionth decimal place, and still haven't found a pattern, so no, it has no pattern. Okay? The pattern never repeats itself, never ends. It's an irrational number. So, what are irrational numbers? They're non-rational numbers, oh, that's a nice way to put it, represented by points on the number line. They are there. This is between 3 and 4, closer to 3, between 3.1 and 3.2, closer to 3.1. You know, and you can keep on going down there. It's a point on the number line, but it's not a rational number. It can't be expressed as a ratio of two integers. Okay? The decimal form of an irrational number does not terminate and does not repeat any fixed block of digits. No matter how big or small, it doesn't. Ever. Okay? I was going to say something else, but let's not even go there. Okay. This starts on page 682 if you're following in the book. Okay. Oh, and by the way, I should have said this too. For every example in the text like we just did, there is in the margin over here, in the gray margin, is that how your book looks? There is another one similar to it. So when we have done one in class, I would say very quickly after class is over with, do the, and what do they call these? Problems. Work problem 1 at the side. I would go back and do this. And here's why I say this. This comes from many years of teaching, basically on my 3rd decade, of teaching. I've had so many times I have students say to me, I understood this when we were doing it in class, but when it came time for the quiz or the test or something like this, I couldn't remember how to do it. And here's what my, at least one attempt at a solution is. When we're doing it in class, even though I'm asking you questions, you're giving me feedback, most of the time I'm doing most of the processing of that to know what question to ask. And it's sort of like you're more the spectator and I'm the performer or something, okay? But as soon as we're through with this, you get and you do the whole process yourself. If you wait too late, like when you get home or something, that might be a little late. Do it as soon as you can after class. If you have a class right after this one, do it as soon as that one's over with. But try to do these problems that are on the margins very soon after we finish class. Okay, let's go back here. Caution. Some square roots are irrational. In fact, I would say most square roots are irrational. Square root of 1 is 1. That's not irrational. Square root of 2, irrational. Square root of 3, irrational. Square root of 4, rational. 2, right? Square root of 5, irrational. Square root of 6, irrational. Square root of 7, irrational. Square root of 8, irrational. Square root of 9 is rational. So you see there's actually more of them that are irrational than rational, except there's infinite number both ways, so how can you say more? Yes?
Why is square root of 2 irrational?
Talk a little
Why
bit.
is square root of 2 irrational?
Why isn't it rational?
Yeah.
Is that what you said?
Yeah.
Okay. Are you thinking you've seen it somewhere before and it looked like it had a pattern?
No, it looks like you can just take it right out. You just put 2. Square root of
Say
2
that again.
Square root of 2 to square root of 2. Square root of 2 is 2.
Okay. Okay. The square root of 2 is a number that when you multiply it by 2, by itself, it becomes 2. Okay?
Yeah.
And believe it or not, that is an irrational number. Do you remember a guy named Pythagoras? He's one of the early, most famous mathematicians, came up with the Pythagorean theorem and stuff. It irritated the fool out of him that square root of 2 was an irrational number. He couldn't believe it. He thought everything had to be nice, pretty numbers, and he found out it couldn't be. Okay. Do you have a calculator on you? Oh, you don't. So, okay. Will it do a square root on it? If it will, does your phone do it? It may. Especially if you turn it sideways, depending on the type of phone. But you'll see, it looks like it's starting to be a pattern. It's 1.414. Looks like a pattern until you get to the rest of the digits, and they never form a pattern after that. There is no simple number that you multiply by itself to give you 2. That's why it's an irrational number. You can try and try and try. It just won't work. It's 1.414, blah, 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 blah. Okay. All those are irrational, except those few that are rational. However, not all square roots are irrational. Square root of 9 is 3. Okay, and that's a rational number, 3 over 1, ratio of 2 integers. Okay. Got it? Okay. That's top of page 682. I think we're ready for example 2. Let's do this. Identify each number as either rational or irrational. Explain why. And you can use your calculator if you would like to see. Anyone want to hazard a guess on A? 0.181818. Yeah, what? Rational. Why? There's a pattern. 18 is repeated again and again and again. How about B? Rational. Why? Terminates. Okay? Yeah. Over with. How about C? Whoa here.
What's irrational?
Second?
Irrational.
Yes, there's a pattern, it seems like, but it doesn't repeat itself. It's 0.202, 202, not 2, okay. And then it keeps increasing the number of 2's in between. So believe it or not, it's irrational. Even though it only has 2 digits and it's 0 and 2, it never repeats itself. Okay? Or it doesn't appear to it. Square root of 11. What do you think? Irrational, yeah. Not one. Square root of 16.
4.
Yes, that's rational. How about 0.36 with a line over it? That's rational. That means 0.36, 36, 36, 36, 36. Repeated pattern. Perfect. Any questions on that? Okay. Let's see how they do it. A, rational, good for them. The digits repeat in the fixed block. Okay. B was rational because it terminates, comes to an end. C, irrational because the digits do not repeat in the fixed block. Same digits, but there's different numbers in between the blocks. Okay. Number D is irrational because the decimal value never terminates or repeat. If you had a calculator, you'd see that. D is rational because it's simplified, equals only 4. And 0.36 is rational because the digits repeat. That's what the line over it means. Excellent. And guess what you can do as soon as you get home or leave class? There's a problem number 2 on the side. More of these. If you have any questions about them, please do them. And the answers are at the bottom. So there's no mystery meat here. You can figure out what the answers are. If you can't figure out why that's the answer, bring them to class next time, and we will do them in class. Any questions? Good deal. All right. Yes. Yes.
I did have a question about E. The square root of 16. So what we're basically doing is trying to find a number that would divide into.
No, not divide.
Okay.
When it multiplies by itself, gives you 16.
Okay.
4 by 4 is 16.
Right. Okay.
Can you give me a number that multiplies by itself will give you 11?
1.
No, give it up. Oh, by itself. 1 times 1 is not 1.
That's right.
By itself.
11 by itself.
Yeah.
So 4 times 4 gives you
4
16.
4 by 4 gives you 16.
Right.
Is there anything that multiplied by itself gives you 11? Nope. Anyone know an answer of why?
It's uneven.
Okay, not even. 9 is not even, but it's multiplied 3 by 3.
It's the same numbers.
Okay.
1 and 1.
Well, that oh, interesting.
It's not,
It's thinking about binary.
I can't think of one right now that might not fit that, but there may be. That's no. Here's the reason. Do any of you remember what prime numbers are as opposed to composite numbers? Say again.
It's like every other odd number. It's an even.
No, it's not even that regular. Okay? Prime numbers are those numbers that only multiply by themselves in 1. That's the only one. Now, you don't count 1, but 2 is a prime number, 3 is a prime number, 4 is not because you can multiply 2 by 2. 5 is a prime number, 6 is not because it's 2 times 3. Okay? 7 is prime, 8 is not, 9 is not, 10 is not, 11 is. Well, not all prime numbers are square root of prime numbers, are not all, just a few of them, but if it's composite numbers, like 4 and 9 and 16 and 25, those are composite numbers that do have square roots, perfect square roots, but there's not a single prime number that has a square root. That's a rational number. They're all. Yeah, I mean, by the definition, the only thing multiplied by a prime number is 1. That's the only factorization you can have. So it can't be something times something, and they'll be the same. So it can't possibly be rational. I don't know. That's probably way more than you asked for, right? Okay. All righty. Now, we talked about counting numbers, which are also called natural numbers. The whole numbers, when you add 0 to it, which isn't much to add, right? And then when you have the positive and negatives, you got integers, and then the ratio of integers is rational, and those that aren't rational are irrational. Okay? Well, what's the next set? The next set is the combination of real numbers, rational numbers and irrational numbers. Okay? Those form what we call the real numbers. Okay?
Every number?
What's that?
Is that just every number?
Every number on the number line. Every number that you can find here. The rational, the irrational, every one of them. Now, later, not in this course, you're going to run into imaginary numbers. Or, yes,
What does it look like?
it has a little I with it. Okay? Not this kind of I, but a little. Okay. And that is like the square root of negative 1. That's I. You can't take the square root of a negative number in the real number system. So you have to come up with a new set of numbers, the imaginary numbers that count those.
Where?
Good question.
Why would you need to find the square root of negative 1?
Because the space.
Well, there are certain things that are modeled better if you have non-real numbers, as in imaginary numbers. If any of you might be thinking of going into electrical stuff, okay, when you're modeling electrical circuitry and you're doing inductors and capacitors and stuff, they actually follow the complex plane. Real numbers and imaginary numbers together form what we call complex numbers, and complex numbers are model electrical stuff far better than real numbers do.
Can you think of
Second?
Talking about voltage.
Okay, voltages, currents, and resistances, that follows real numbers very nicely. It's only when you get into inductors and capacitors and things like this,
Oh, they have
then,
electric
yeah,
current.
then you can model better with the others. Another thing, any of you into astronomy, like black holes and stuff like that, when you're modeling those are so weird. They fit far better in the imaginary concept because things get sucked into them and never come out again, okay? So that's like, in complex numbers, we have what they call singularities. And the best thing to model a singularity with is a complex number, okay? That's way beyond this course. But there are circumstances where complex numbers do come in a little bit handy. Not most of the time. Not in the things you'll be
You
dealing
teach
with.
that stuff, right?
What's that?
You teach that stuff, right?
Yeah, I keep on going up. Yeah. In fact, I get to the point it doesn't make any sense to me either. So don't feel like the Lone Ranger. All right. Yeah, but I teach calculus 1, 2, and 3, and differential equations, linear algebra, all that kind of stuff. And I've had courses in the complex number system, but we don't teach any here. All right. So all numbers can be represented by points on the number line, and every one of those, the rational and the irrational, they make up the real numbers. Set of real numbers includes all the rational numbers and all the irrational numbers, and all real numbers can be represented by some point on the number line. You don't have to get into the complex plane. Okay? So that's real numbers. Now, there is a nice little graph on your page here that is not showing up on the slide set. And not all of you have the book, so I'll try to highlight it here. Okay? Remember, we started with the natural numbers. Those are the counting numbers. 1, 2, 3, 4, 5, 6, all those numbers. Whole numbers, you just add one more number to it, 0. So that's an awful big square just to have nothing in it, okay? And then when you do the positive and negatives, that should be twice the size of this one, and that would be the pink rectangle. I said squares, rectangles. And then the rational numbers would be any ratio of those integers. And then, this is rational numbers. On this side, we have the irrational numbers. Now, there's no reason for that box to be smaller than this box, because they're both infinite, okay? But they just made it smaller. But then the real numbers would be all of the above. Both of them. All right. Ready for the next objective. Using our inequality. Does anyone know what this symbol stands for? It's not equal to. If it was just this, that is equal to, right? But this is not equal to. That's the slash. How about this one? No, this one's less than, okay? Here's one way I heard it at one time. The smaller part is pointing to the smaller number. The bigger part is toward the bigger number. So this is less than that, okay? This one would be less than or equal to, greater than or equal to. These are used to compare real numbers, things on the number line. Okay, let's just say, here's a point on the number line right there. How would you say it compared to that point on the number line? Greater than. How about this point here? That's a negative number. How about this one? That was greater than this. Even though the number here, that would be -5, this would be -15. But -5 is greater than -15 because it's to the right. To the right on the number line. Okay? So, those are this. Our is equal to. Interesting little statement here. 3 times 7 is equal to 7 times 3. Does that ring the bell? Called the commutative property of multiplication. You can multiply this way or that way, they equal the same. Addition and multiplication, you can do that with. Don't ever try it with division and subtraction. Doesn't work there. Only multiplication and addition. But that's what it means. They're the same. Is equal to. How about this? -2 is less than 0. Of course, you didn't think much could hit less than 0, but it can. How about 0.65 is greater than 0.6. Half or more, 5/100 more than 0.6. Not equal to, this is one like we were just saying, you can't commute subtraction, so 3 minus 7 is not equal to 7 minus 3. Plus, yes. Times, yes, but not subtraction or division. And 1/2 is not equal to 0.3. What is 1/2 equal to? 0.5. Good deal. Okay. This is a rather strange one. 3/4 is equal to 3/4, or it's less than or equal to. Either one is equal to. And -8 is equal to -8, but it's also greater than or equal to, or less than or equal to. And also here, sorry, I didn't see these. 0 is less than or equal to 4 because it's less than 4. 3/4 is less than or equal to 3/4 because it's equal to. So it can be either or. 1.25 is greater than 1.2 because it's greater. -8 is greater than or equal to -8 because it's equal to. So either greater or equal or. Yes?
How is 0 equal to 4?
Okay, it doesn't. It says less than or equal to. Or. It happens to be on the left-hand side. This is on the equal to side. This is that one. This is that.
Okay,
This allows both of them. What's that?
How do you do an if equation to make that true? That if
How do you
equal
what?
one, then it's equal one way and it's less than the other way.
Okay. Well, okay.
I know, I just threw the
Yeah.
skill way.
Okay.
Yeah.
Yeah. This seems sort of trivial right now. You think, what's the point? Later, a few courses from now, you're going to get into the thing of talking about domains, okay? Which would be what numbers can fit into this thing. And if we did something like this, x, let's see, is equal to the square root of y. Let's do it the other way. Let's do y is equal to the square root of x. That's the way we usually would say it. Okay. Oh, yes. All right. Now, you're not there yet, so don't worry about this. Okay? What values could x take on here?
1.
1 would be fine. Second? Yeah, actually, any real number. Any positive real number. Because you can't put a negative sign in there and be in the real number system, can you? So if 0 would fit, you can take the square root of 0. It's 0. 1, 2, 3, 4, 5. You can take the square root of those. You can't take the square root of -1 in the real number system. So therefore, we would say the values of x that are allowed here would be x is greater than or equal to 0. That's how you use this. Okay? Meaning that any x that's either greater than 0 or equal to 0 fits. Okay? If you had y is equal to 1 over x, what would you say about that? What x's could go in there? Positives could go in there.
Same thing, all real.
Say again?
All real numbers?
Except 1.
That's 0.
0! So this one would be x cannot equal 0. That's how we use this. We don't usually use it with numbers on each side. We usually use it in a mathematical sentence,
So it's connected.
identifying what values would be what. Okay?
So it's connected in some way.
Yeah, it shows in connections. Exactly. That's what it's used for. So yeah, it looks sort of stupid to say 0 is less than or equal to 4. It's not ever equal to 4. It's always less than 4. But that's a correct statement because it's less than or equal to. So yeah, if it fits either one of them, it's fine. Okay? But most of the time we use them in sentences with variables in them. But we haven't really gotten there yet. Okay. So, here's example 3. Label each statement as true or false and explain why. There's the first one. 6 is not equal to 1. True or false? True, yeah, because it's not equal to what kind of why can you say about that? True, good. How about this one? 9 is greater than or equal to 5. Yes, because it's greater than. Perfect. So that's true. How about this one? 8 is less than 4. False, because 8 is greater than 4. Okay. How about 1 is greater than 2? False, because 2 is greater than 1. Okay. How about E? 6 is less than or equal to 6. It's true because of the equal sign. If the equal sign wasn't there, not true. But if with the less than or equal to, or even greater than or equal to, or just equal to, all those would have been true. And that one is indeed true. Does that make sense? Good deal. Okay. Guess what? On the margin, you have 6 more that you can play with. Okay. If either the less than part or the equal part is true, the equality less than or equal to is true. It's an either or. Okay. Now, they call this converting inequalities. Okay. Interesting thing to call it. It's not showing up in the book that way, but it's fine. To convert between less than and greater than, reverse both the order of the numbers and the direction of the symbol. Okay? Yeah, okay. That's what they're doing here. So, here's example 4. Let's just do an example before we get to 4. Okay? They showed us this one. Is this a true statement? Yes, it is. How can I express that same concept, but with a different inequality? 10 is greater than 6. That's all they're getting at. Nothing is not rocket science. It's just, if you reverse the numbers, you flip the sign.
Is this the and and or stuff?
Say again?
Is this the and or stuff?
Well, with the equal sign under it, you've got the or stuff. This is just, I think I know what you're talking about, and it's similar, but not quite the same thing. But yeah, but the if you had less than or equal to, that's an or, and that's still true. And this would be greater than or equal to, it's still true. Now, if that was a not equal to, you don't reverse a not equal to, it's still not equal to. So there's no reversing those. You can put them on the other side, like 10 is not equal to 6. Yeah, still true, but you haven't changed the sign at all. All right, good deal. So let me erase that. And let's go on to example 4. There we go. How would you change this sentence?
2 is less than 15.
Say that again.
2 is less than
2 is less than 15, and that would be 2 is less than 15. Okay? I bet you they do the same thing. Let's see. Yeah, there it is. Let me take off my writing here so it doesn't mess it up. Well, they put the 2 in the 15. Now they got one more thing to put the sign in there, and I did it already. That becomes the less than sign. You reverse the symbol. That only works for the directional symbols. Okay. All right. They just did one there. Okay. I guess it's going to do the next one. Yeah. Example 4. Oops. Okay. What would this become? Oh, we already did that one, didn't we?
Yeah.
10 is
That
what?
was in the book.
Say again?
That one's in the book.
Yeah. Oh, wait, let me go back. This is confusing me. Oh, that's 15 and 2. Okay. I see. No, they're not in the book. Oh, I see. Got it. Yeah, this is another example in the book. It's not example 4. It's before example 4. Okay, same thing as before. 6 is less than 10. You change that to read 10 is greater than 6. Good deal. Like that. Okay. They skipped most of the example. That was all before the example. Let's go back and let's do the rest of the example. Okay? You tell me what to write. 9, 16. Yes, it's less than. And if you reverse them, 16 is greater than 9. Perfect. Anybody have a problem with this? How about this one? 0, -2. Okay, what do I put the way I've written it here? Say again?
It's greater.
Yes, 0 is greater than -2, and if you reversed it, -2 is
0.
less than 0. Perfect, perfect, perfect. How about this one? We love our fractions, don't we? 1/2 and 3/4.
Less than.
Okay, in the book they have the less than or equal to, and since they did it that way, if you put the 3/4 here and the 1/2 here, what would you put? Greater than or equal. You don't have to have the equal sign there, but it's okay. Okay, how about this one? -7 and -8. What symbol goes there? Greater than, you're absolutely right. And they actually had greater than or equal to, is fine. So if you did it -8 and -7, that's less than or equal to. Okay, it's less than, I agree. Okay, what I do, think of the number line. If it's to the left of it, it's less than. If it's to the right of it, it's greater than. So it's -7, 8, 9, 10. -8 is to the left, that's less than -7. Okay. Don't pay attention to the value, pay attention to the sign and the value. All right, good deal. All right, now, using order of operations to simplify expressions. I think we no, that was a different class, sorry. We've been using parentheses to show several things. For instance, in this case, when you have a number, parentheses, another number, what does that mean? Second?
Multiplication.
Multiplication, you got it. 3 times 5, you read well. Okay. Now, if you have a sign in front of a number in parentheses, okay, now, I'm pretty sloppy with this, and I imagine you will be too. Actually, the way you should read this is 6 minus a -4. That's the same symbol there and there, but we don't say 6 negative a -4. You could say that, but it's usually better to have the operation being subtraction or minus, and the change of sign make that the negative.
Or if you can't see that, you put a 1 in front of parentheses. When you multiply two negatives, they become a positive.
Okay, I see what you're saying. Yeah, that's a very good way to think about it, and that's perfectly fine to do that. If you don't see a number in front of a variable, which we haven't gotten to yet, or a parentheses, you can imagine there's a 1 there. Whether it's a plus in front or whatever, okay? So then this would be 6 minus 1 times -4 is? 4. Plus 4, 6 plus 4 is 10. We're asking you to do that, but since you said it, I'd say go on to that. That means 6 minus a -4. Now, if you think number lines on these, you can get dizzy, But actually, the other way to look at this, whenever you have a signed number after a subtraction, change the sign and add. So that's the other way to do it. Yeah.
Like wrong sense versus the one actually there.
What's that again?
Is the one actually there?
In reality, yeah. You can put in 1 anywhere you want to, because it doesn't usually change the value. Like 5, that's also 5 to the first power, isn't it? It's 5, So you can put a 1, as a coefficient. You can put a 1. Yeah, it doesn't change anything. Okay? So, no, it wasn't there, but I put it there, but it didn't change anything. It's sort of like, and I'll ask this question in the future too, I'll say, and when can you multiply by 1? Anytime you want to. Or divide by 1? Anytime you want to. It doesn't hurt. It doesn't change the value in it. Okay? So, yeah, you can multiply by 1 anytime you want to. Okay. How about this one? Yeah, that's a order of operation. I call it grouping. Okay? This is saying, rather than adding 6 plus 3 and then adding 4 to it, add 6 plus 3 plus 4. 3 plus 4 is 7, and 6 plus 7 is 13. But guess what? It doesn't matter what order you did. If you did 6 plus 3, 9, add 4 to that, 13. That illustrates the associative property of addition. And that works for multiplication too. It doesn't work for subtraction and division. Okay? But that means do that first. Whatever is in parentheses. Remember the little acronym? Do y'all Ever learned that? Please excuse my dear Aunt Sally. I don't know what she did, but or Sue or whoever she is. Okay, but you always do parentheses first, exponents next. We haven't even gotten there yet. Then you do multiplication, division in whichever order it comes up, and then adding and subtracting in whichever order it comes up. And since this is all adding, it really doesn't matter. But with the parentheses, yeah, do that first. Okay. Now, an expression with double parentheses like that, what do you do with that? Start at the innermost and work your way out. Okay? So you start with this. 6 plus 5 is 11. Multiply that by 3. 33. Add 8 to it.
42.
Okay, yeah.
Yeah. No.
41. Okay.
41.
And then multiply 2 by that. 82. All right. Calculators are going sort of rough, but they're going. Okay. So that can be confusing. And here's what they say. And by the way, are any of you computer programmers? You may not be yet, but you're probably wanting to get to be someday. Computer programming, they always just put in parentheses. In calculator, they always put in parentheses. What they suggest here is to identify what goes with what. You square brackets instead of one set of parentheses. And if you have 3, what they call nested parentheses, then the third one you use braces. They're harder to write, but use that. So, but anything more than 3, you got to start repeating. We don't have any other symbols, but most of the time you're not going to have any more than that. You don't have to do that. That's perfectly correct. You just have to keep up with it. And that's the same thing true with your calculators. When you are doing things with them, if you open a parenthesis somewhere, you better close it somewhere else. Otherwise, the calculator sometimes will give you right answers and sometimes will give you wacko answers. So you have to know what to expect. Okay? Any questions on that? Okay. So is that the one we just did? I think so. Let's do it again. What do you do first? 6 plus 5 is 11, and you do 3 times 11, and then that would be 33, and then you add to that. 8 would be 41, and you multiply that by the 2, and you get 82. Okay. Now that's not the best way to write. You should write down all the numbers, but I'm just plumb lazy. Okay, so as long as you know what's going on, you really should write all the numbers down. Let's watch them do it. I bet they'll do it right. Okay. Oops, that's not what I wanted to do. Okay. Okay. Let's watch them do it. Begin with the innermost parentheses and work your way out. Then follow the order of operations before you complete the work inside the brackets. All right, they put the brackets on the outside. Oh, they did that too. I hadn't even noticed, okay? So start this, and you do 6 plus 5, that's 11. So it's 2 times 8 plus 3 times 11, close, close. Then you multiply the next thing. Why do you multiply this before you add that? Please excuse my dear Aunt Sally. Do the multiplication before the addition. Okay? So 3 times, yes?
What's the actual standard that's called?
What's what?
What's the actual standard that's called? What's the actual standard that's called? Yeah.
What's the actual standard?
Yeah.
That's pretty much it. This is called rule of order of operations. That's what it's called. And I don't know of a better way to say it than the other. Always parentheses and exponents, then multiplication, division, whatever order, and then adding and subtracting. Yeah.
If I did it different, I get a different answer. Why did I consider it?
Okay, say that again.
If I did it different and I get a different answer, why did that be considered?
Because you followed the rule. No.
Correct order of operations.
Yeah. Now, let me warn you about this. The nicer, better calculators will follow rule of order of operations. They'll do whatever you tell them to. So, in other words, if there needs to be a parenthesis there, you better put it there. Okay? I'll give you an example of that. if the problem was this, 2 divided by 8 plus 3 times 6 plus 5. Okay, that looks like what we're saying. I'm sorry, that's not divided by, that's the times. Duh. I was going to change the problem, but I decided not to. Okay. Okay. Now, if you were punching in the calculator and did this, when you do 2 times 8, it's going to calculate that be 16. Add 3 to it, but it's not going to do. It's not going to do that. It's going to add 3 times 6, which is 18. So it's going to be 16 plus 18 is 34 plus 5 is 39. Wrong answer, because it's not doing the order of operation. So therefore, if you have a multiplying, but you're going to do this addition before you multiply, you have to put that in parentheses. You're going to do that addition before you multiply, you have to put that in parentheses. That's why the parentheses come first. That overrides the regular rules. And so many times, people will get wrong answers, especially when you're doing division. That's why I started right at division. But I'll just go into this. Just gives you wrong answers. You have to be very, very careful. You're plugging things in the way you want to. I mean, that's what the signs are saying, but that will give you a wrong answer because of the rule of order of operation. Okay. So we add that, we multiply that, we got 82, good deal. Not whatever we got up there, 49 or whatever. Any questions? Good deal. That's example 5. For example 4, there's a problem on the right, on the left, it is in the margin, and for number 5, there's another one in the margin. Please do those as soon as you can after you get out of class. It may be this evening if you got classes all afternoon or you got to go to work. But as soon as you can, try to do the marginal problems.
What page is that?
That was on page 684, those two. Okay? Let's go to 685. Removing parentheses using the distributive property. All right, we've introduced a variable here. Y'all are used to it, right? Okay, good deal. The y is a variable. Say again?
2y minus 6.
Okay. About one more time. Negative 4y. You multiply the negative 2 by everything inside, and that would be a negative 4y minus 6. You're absolutely right. You multiply the entire entity here, the sign included, by this, and you multiply it by that. Okay? That you would be writing without parentheses. Okay? Any questions on that? Okay. They sort of skipped the introduction to this, so let me go back. Again, this is my first time teaching this book, so let me go back and do this. We probably should have done it before. What does this mean? 6 times y plus 4. 6y plus 24. Everybody see that? Okay. How about 5 times 3x minus 2? 15x, second, minus 10. Perfect. How about 6 times y plus 6 times, oh, I'm sorry. That's just doing the same thing here. That's saying 6 times y plus 6 times 4. Okay. I'm sorry. I thought that was a different problem. Yeah. Y'all did it without going through all the steps. Fine with me. Okay. So let's go on to, wait a minute. Oh, this is a previous problem. Okay. Okay, there was A. We did that. Oh, wait. Let me clear this out of the way so you can see it better. All right. Why they moved it over there, I'm not sure. All they did was write negative 2 in red. So negative 2 times 2y plus 3 would be negative 2 times 2y plus negative 2 times 3, which would be negative 4y plus a negative 6. which would be negative 4y minus 6. Okay. That's sure is a long and to me more complicated, and the more steps you put in there, the more likely I am to make a mistake. So I like to, I'm sorry, have y'all heard of KISS?
Yeah.
Okay, yeah, I'm sorry. I go with that most of the time. Y'all know what it stands for? Yeah, you got it. I don't usually use the stupid part, but yeah. The more steps you put in, the more, it seems like more places you could make error. But if you can't see a step, put it in, okay, by all means. Okay. That seems like it's overdoing it. Let's do the B part. You tell me what to do. Whichever. What do you see?
Negative 15a plus 9.
Does everybody see that? Anyone disagree with it? Okay, what you've done there is negative 5 times 3a is negative 15a. Negative 5 times negative 4 is positive 20. See it?
Why you change the subtraction to
Negative times negative.
Yeah.
Okay, that's a very good question. Anytime you have a negative in front, it's going to change both signs inside. Think of this. Let's go back to the previous one. That negative 2 in there, this was a plus plus, it becomes a minus minus. Okay? Second?
It was a positive, which leads to a negative.
Yeah, no, it leaves everything the same. Positives don't change things, negatives do. Okay, see here? A negative front. Yeah, a positive times positive is positive. Positive times negative is negative. It doesn't change the sign. But a negative changes the sign. This is a minus times a plus minus. That becomes a minus plus. It changes both signs inside. Good little thing to keep in mind. Then deal with the numbers too. Yeah, don't forget them. Okay? So, any questions on this? I know I talk sort of fast, but don't let me ramble on. Stop me. Ask questions. Otherwise, we'll finish the course in 3 weeks. No, just kidding. We won't do that. No. All right. Now, they're going to carry it out in gory detail. They're going to say, first, it's negative 5 times 3a, plus, well, they'll put a minus a negative times 4 or something like that. Yeah, that's what they do. And again, putting too many steps in just confuses the issue. It's correct. Everything they said is correct. And that's negative 5 minus a minus 20, 5, negative 15a minus a minus 20, which makes it negative 15a plus 20. Okay. If you can do it without it, and it makes sense to you, do it. If that doesn't make sense the way we did it, and this makes sense, do it this way. Do whatever makes the most sense to you. Right? All right. Now, caution. Watch the signs carefully when there's a negative number in front of the parentheses. I think we just hit this. Notice that every term inside the simplified expression has the opposite sign from what was inside the parentheses. We just said it, so we're ahead of them. We were cautious before we started. Okay. Now, let's do example 8. They seem to be skipping. Yeah, they skipped example 7 completely. Okay? Okay, let's do example, well, even before we get to example 7. What does this mean? How could you write that expression without parentheses?
Negative 3x minus 5.
Absolutely. And this, again, you can think of that as a minus 1 if you want to. Or not, it can just be a minus sign. Minus goes in here, that would be minus 3x, and minus multiply with that, and it gives you a minus 5. So that would be a minus 3x minus 5. Very good. Okay? Or you could put the 1 in front. And again, there's problems in the right-hand margin. Do them. Okay. Now let's do example 7. I think I'll erase this. Whoa, wrong thing. Let's back up and do this. All right. We just did it. Okay, I'm sorry. We just did the A part. Let's do the B part. What if you had a minus a negative 7r minus 8? That would be a 7R plus 8. Does everybody see that? And see why? This minus changes that sign, this minus changes that sign. Yep. 7R plus 8. And another thing just to notice here, your variables are always X's and Y's. It can be A's, B's, C's, R's, J's, Q, whatever. Okay. Got it. They have a problem 7 on the side in the margin. Do that. So I think we're ready for example 8. Y'all ready? Okay. There we go. Woo. Okay, what are we going to do with this one?
10A squared minus
All right. Okay. 10A squared. You see that? Next.
30A
Minus 30A.
minus 20A squared.
Minus what?
20
All right. 12A squared
plus 27.
plus 27. Does everybody see that? I know we're doing sort of fast. Does that make sense? Everybody following? Okay. Now what?
Combine
Combine like terms, and what do you get?
-2A
Negative 2A squared
30A
minus 30A
plus 27.
plus 27. Hike. No, that was football. Okay. All right. Now, for those who did that little pretest that we had that very first day, boy, I saw some creative things going down there and combining like terms. Let's not be creative. Let's do it the way it's supposed to be done. Remember, you can only combine like terms. If you got a variable in there, it must be identically the same variables at identically the same powers. There's no way you can combine these two because that's the second power, that's the first power. Because if you don't see a number, you understand it to be a 1. Okay? And you can't combine the other things either. So yes, everybody see how that works? All right, good deal. All right?
Mr. Fowler?
Yes.
I'm just looking at it. Okay, so 5 times 2A is 10A squared, minus the 38. And we got that by 5 times 6A.
Yeah.
Gave us 38 squared.
Not no A squared. 5 times 6A would be just 30A. with
Okay,
a minus.
38. Okay, and then, and so what gave us, how did we get to 12?
Okay, minus 3 times 4A squared. You see it? Minus 3 times 4 would be minus 12 with the A squared. You see?
Now, if you had an exponent in front of, or a
Coefficient.
5, it'd square that 6A.
Yeah.
That'd be
Say that one more time.
I said if you had an exponent with that 5, it would
Okay, you mean
square.
a variable with 5. Yeah. Okay, yeah, if it's been a 5A, then it'd been 5 times 2 would have been 10 still, but A times A squared would be A cubed then.
Oh.
Okay, so
So it
only
used to be 12, yes.
Yeah.
3 times
12
4
A squared because
is
there's nothing
12A
here, and there's
3
no A
times
here.
9 and 26.
Positive 27.
Okay. And then to come down below there to get the negative 2A squared.
Okay.
How do we?
You look for like terms, okay? And the like terms here, this is an A squared, that's an A. Those are not alike. This is an A squared, that's an A squared. Yes, those are alike. So now you combine the coefficients. 10 minus 12 is
2.
negative 2
Oh,
A
okay.
squared. Now, okay. Now, I admit we were skipping steps like crazy. And sometimes that's not a good idea. If you want to, this would be a very good thing to do. Okay? Don't skip steps just because I do. Combine like terms. 10A squared minus 12A squared minus 30A plus 27. Okay? Now, these two both have A squareds in them. So you could write that. You're going back and introducing parentheses now. 10 minus 12 times A squared. Get all those with the A squared together. There's no other with the A, so that's just 30A plus 27. And what's 10 minus 12? Negative 2. Now, if that makes more sense to you, do it that way. Okay?
Thank you.
Do whatever it takes to make it make sense to you. Okay? Just because it makes sense to me doesn't mean, in fact, you're sort of sick in your head if you can follow my logic sometimes. Well, that's what my wife tells me anyway. No, she didn't say that, would she? Okay. All right, so there was example A. Goodness gracious. That was AC. They skipped 8A and 8B. Let's go back and do those. I don't know what's this book doing here. Okay, let me erase this. Like I said, first time I've taught this, so I'm not used to their little things of doing. How about this one? 14y, why not, plus 2 times 6 plus 3y. Where would you begin on a problem like that? Okay, start with the parentheses. That 14y, just leave it hanging there.
Plus 12.
Plus 12
Plus 6y.
plus 6y. Perfect. Now what?
20y.
Combine like terms. That would be 20y plus 12. Does everybody see that? Yes. Homework? Is it that time already? Not yet. Huh?
I gotta leave at 3 actually.
Oh, I see. So you're late leaving.
Yeah.
Okay, homework will be the exercises at the end of the section, the odd numbers, because those answers are in the back of the book. Okay, and you can go to My Math Lab, and I think you can see these very same exercises there if you use that. Oh, no, you can't yet because I haven't gotten this one to work yet. So.
Can we not see it in the ebook?
Yeah, you can do them all. You can do all of them.
Can you tell me what page it is?
Okay, that's on page 687, 688. We're going to be here just because he's leaving. We are all leaving. We don't follow you like the Pied Piper, okay? Okay, right here. I thought he wanted to take my picture, but it's just the book he wants, okay? No. Wait, here's the next page. Yeah, this page here.
This whole page?
Yeah.
Oh, man.
Yeah, I don't expect you just twiddling your thumbs all weekend.
I didn't work so much.
Okay. All right, so there's 8A. Let's do 8B. A minus 2 minus R plus 10R. What would you do on a problem like that? Okay. Where do you start? All right. You're still here. Negative 2. What? Plus R. Okay, very good. Does everybody see why that is? Minus in front goes across both terms in the parentheses. Okay. What next? Plus 10R. Are you through? Are you through? Okay, he rearranged the order. That's fine too. 11R minus 2. Now, there's a perfect example of why I don't really take My Math Lab too seriously, because I bet you My Math Lab would want the answer is minus 2 plus 11R. And if you put this down, they say wrong, and there's nothing wrong with it. Okay? In fact, I like that answer better because I don't like leading off with a minus if I can leave off with a plus. But it doesn't matter. They're both correct answers. But you see, these computerized packages, they only recognize one answer even though there may be many correct answers. Okay. And remember, there's problems on the side for every one of these. Now, homework exercises in 10.1. If you got your books, if not, you can come take pictures of me or my book. No, the book. Okay, don't take pictures of me. Break your phones that way. Okay, do any of the odds. And let me just check and make sure. Is it? Whoa! Let's see. Yeah, it's only odd answers in the back. So any of the odds 1 through 9. Do number 11. Any of the odds 13 to 17. Either 19 or 21 or both. Any of the odds 23 through 33. Either 35 or 37. Either 39 or 41 or both. And any of the odds 43 to 53. Okay? I was afraid someone was going to say that. Any of the odds 1 through 9. Do number 11. any of the odds 13 to 17. Do either 19 or 21 or both. Any of the odds 23 to 33. Either 35 or 37 or both. 39 or 41 or both. And any of the odds 43 to 53. Okay? Oh, we have a minute left. Too bad we can't get started in the next section. Yeah, because y'all have been so good this week, I'm going to give you the next minute off. Okay? Y'all were that good this week, I'll tell you. Okay. We started off with close to perfect attendance last time. This time we weren't quite as close, but we missed one person last time, 2 people this time. Good attending class, way to go, keep it up. Any questions?
I do have a question.
Okay. Okay. Yes, sir. What's that?
The homework that we did, when I give it to your keeper.
Well, did you get them all right from the back of the book?
I'm pretty sure. If not,
Okay.
I could
If not, then bring the ones that you're having trouble with, and we'll go. Yes, sir.
What's the first test?
We're going to have 4 big tests. We're going to have some quizzes beforehand. So this is what even though it's only our 3rd time to meet, let's see, 16 weeks divided by 4. About every 4 weeks we'll have a test. So, yeah. So
next week we may take tests.
we'll probably have a quiz next week.
Okay.
Hope so, anyway.
What's it gonna be on?
Chapter 10. What we covered in chapter 10.
Thank you.
Yes, sir. You too. Thanks.
I have a quick question.
Okay.
I got different book.
Oh, okay.
So can you tell me what problems I have to do in this
Okay. Is it sort of the? Yeah, this is sort of the same stuff. I bet you the odd numbers are in the back. Can you do the odds on those?
Are you gonna take homework though?
No, only if you're having trouble with it. I'll see if I can figure out what you're doing wrong.
Okay.
Okay. If you're getting them right, fantastic.
Okay, thank you.
Okay. Yes, ma'am.
I'm kind of a little confused again. Okay, but I'll tell you what are next. So, negative parentheses 2 minus r plus 10r. And I understand how we got the -2 here brought
Right.
down, plus because the 2 negatives changed to a plus,
Right.
r plus this
Then
10r.
let's bring that down.
Bring it down. And then how do we get the 11r? I know.
Okay. Now the guy did it. The way you probably would have done it was -2 plus these have the same terms. These are like terms.
Yes, sir.
1 plus 10.
Oh, because
Remember?
anytime,
Yeah.
that's
Anytime
right.
you don't see a number, understand it to be a 1.
One.
Yeah.
And that used to trip me up, so I took the 90 like twice, 3rd times. Oh my God, because it just always would trip me up until I got it. So now I understand.
Right.
1 plus 10, 11, or, okay.
And
Negative.
minus 2.
Yes. Okay. And so I'm going to take a picture and I'm going to go in with the code and I hope I can pull up my math lab because
Right.
It does have an ebook. And
Yeah.
so I can flip through and
Right.
that's what I was asking in the page numbers. And I want to make sure I got the right page number, Mr. Fowler.
Okay.
What page number did you give us? I have all the odds and the evens that you want us to do, but what page number? Did I get that correct? 687 and 688?
That's correct.
All right. And I'm just going to take a picture to make
Okay.
sure if I can't hit it.
I just thought you wanted to take a picture of me. No, I'm just kidding. It's this one.
This one, okay. I thank you, Mr. Fowler. To be honest, I'm understanding it more with how you're teaching it. I don't know why
I
than
don't
with
either.
some of my other teachers. And they were excellent.
Oh, I know they are.
Yes, but I don't know. Okay, I got that
And-
page. And I'm trying. I hope I have the whole page. I can pull it close. Let me get it. Thank you, sir. All right. Yes. So Lord, I can appreciate understanding it. I'm not so behind. I think initially when I started out,
Right.
and then I guess I have the children in here about 20 years. So, when we get a little older, we're just not as fast to we can comprehend it. It takes a minute for it to just get in there
Right.
and do its thing. So these kids are quick. You know, you can give it to them and they understand it and they put. And I am still on when you say 14Y plus. These kids done already finished the problem. I'm like,
Some of them maybe. Others of them are just as clueless.
yes,
So,
and Ms. Martin said, Patricia, because you ask questions, it's good.
It's
They're
very
not going
good.
to ask questions because, see, they're embarrassed. They're the kids. They're thinking other people are looking at them. They don't want nobody to think that they don't know. But, see, you're at a whole different total place, and I don't care who knows. I don't know it. I
Right.
need to get it.
Exactly.
Thank
In the Navy, they used to have a saying, there's no such thing as a dumb question
That's right.
unless you don't ask it.
That's right.
That makes it dumb.
That makes it
But
dumb.
if you ask it, it's no longer dumb.
It makes sense to me, Mr. Fallon. Thank you.
All right,
Have
glad
a
to.
great
And if I
day.
ever get going too fast, just say, hey, put on the brakes, guys. You know, I don't mind.
Yes, sir.
Okay.
All right. I'll see you next week.
All righty. Have a good weekend.
Thank you.